Okay, so we are going to start off with some topics about negation. Our first example is going to be if you're given a situation where A or B, so keyword here is or, and it will negate to not A and not B. One way to see this is if you look at a Venn diagram where this is A and that is B, and it's all inside of the universal set, then A or B will consist of all of this right there. But if you want to see the negation of it, not A and not B would consist of all of that. Now I am going to be using the same A and B for the next 4 examples. So I've let A be defined as the people who love animals, and I let B be defined as the people who love food. Therefore, then A or B, either people love animals or people love food. Then the negation of A or B goes to not A and not B. Therefore, which equals people don't love animals and people don't love food. So the key things that I changed here are the or and the and, as well as changing it from people who love food to people do not love food. So the next topic we are going to be covering is if A and B negates to not A or not B. So the key things that changed here are the and to the or. To see this visually, if you think of a Venn diagram again, where this is A and B, if it's in both A and B, then it consists of this right here. But if it's not in A or it's not in B, then consists of all of that. Using the 2 definitions I laid out of A and B before, where A equals the people who love animals and B equals the people who love food, then A and B will equal people who love animals and people, hold on, and people who food. The negation would be not A or not B, which equals either people do not love animals or they do not love food. So as you can see, the key changes from here are the either, when you go from an and to an or. Also, we changed it from people who love animals to people who do not love animals. A third topic that we're going to cover is the if, nope, is if A, then B, which implies the negation of it is A and not B. And this may be a little confusing to think about if you want to see it visually, but if we start off with our usual Venn diagrams of A and B, which will get negated, so if A, then B happens to consist of this. Meanwhile, the negation of it would be everything that isn't covered in red. Therefore, the negation is what is only in A. Then the above statement starts to make sense. A and not B. Therefore, everything in A that isn't in B. So now if we use our two statements, if we have A equals people who love animals, and B equals people who love food, then if A, then B would equal if you love animals. That's not really good. If you love animals, then you love food. But the negation is A and not B, which equals people who animals and people who do not love food. So the next topic I want to cover on negation is negating quantifiers. So the two we're going to be focused on is there exists and for all. So for there exists, it can be written as some or there is. The main point of there exists is there's less than everyone and more than no one. For all, it can be written as all or every. The main point of for all is that every single person in that group is included in it. And now to negate there exists, so to negate some or there is, basically you want to include everybody in it. So the negation of there exists is for all. And the negation of for all is there exists. So we'll write that out a little bit cleaner. There exists can be negated to for all And for all can be negated to if there exists. Let me just clean that. So now as an example, there exist people who love food. The negation of that would be for all, or every person loves food. And then you can go back from every person to there exists. But that's basically all you need to know about quantifiers.